Hello student, today we are going to study our topic matrices. This is very new topic for you all. Here in this lesson, very first we will see what do we mean by the word matrix. What do we mean by the word matrix? Matrix is a rectangular arrangement of the numbers. Okay, we are arranging it vertically and horizontally. Okay, and we write it in the brackets or parentheses. Okay, we write down it inside the bracket or we write down it in the parentheses. Okay, then here you just see this example: 2, 3, 4, 5, 8, 9. These are the numbers which I have arranged, okay, which I have arranged horizontally and the vertically. Horizontally I have arranged it and I have arranged it in the vertical manner. So this is what, this is your matrix. This is your matrix. The horizontal lines in a matrix, it is called as row. Okay, this horizontal line, okay, this horizontal lines, it is called as what? Horizontal lines are called as your horizontal lines, we called it as rows. Okay, whereas the vertical lines, okay, this vertical lines, this we called it as column. This vertical lines are called as what? The vertical lines are called as columns. We called it as columns. And the each term, it is called as entries or element, like 2, 3, 4, 5. These all are what? These are called as elements. These are called as what? Your elements. For example, this 9 is what? This 9 we called it as an element. Means each of the terms inside this matrix, it means what? It means your elements. Okay. Even we called it as entries. Even we called it as entries. Then you may be thinking, what is matrix? Matrices. Matrices is the plural of your word matrix. Okay. The plural of the word matrix is called as matrices. Okay, and why we are using this word in this lesson? Because here we are not going to study about just a single matrix, but we are going to study about various kinds of matrix. That's why we are using words matrices. Clear? Now the next term which we are going to see is our order of matrix. The next term is order of matrix. A matrix having m rows and m column is called as m into n matrix, or a matrix of order m by n. A matrix, I'll just write down the definition so that I can make you understand in a proper manner. Now let's see. Matrix having m rows and n column. Okay, if a matrix is having m rows and n columns, we called it as what? Matrix of m by n. It is, see here I have written it m by n and we read it as m by n. Okay, or we say it a matrix of order m by n. Now here you just see here one example. Let A equals to 5, 8, minus 3, 9, 4, 2. Okay, these are the elements of your matrix. Now these are what? This is your first row. This is your second row. okay, and this is your first column, this is your second column, and this is your third column. This is your first row, this is your second row, this is your first column, this is your second column, and this is your third column. The order of this matrix is what? You know, as we are saying, we are writing it in the form of m rows and n columns. So here of this matrix, how many rows are there? In this matrix we are having 2 rows, okay, so that I will mention it over here 2. And how many columns I am having over here? I am having here 3 columns, so I will write it as like this 3. So if whenever we are writing, how we will write it? 5, 8, minus 3, 9, 4 and 2, okay, and the order is written on its corner, okay, the order is written at its corner. So this is what here, this 2 represents your number of rows, this 2 represents what? Number of rows, okay, whereas 3 represents what? 3 represents your number of columns, okay. So this matrix is of order what? 2 by 3. This matrix is of order 2 by 3. Then how many elements do it have? Order of matrix is very simple. If a question is coming, you must be answerable to it. Okay, what is the order of this matrix? 2 by 3. The number of elements, if they are asking how many elements it is having, so what we will do? Just multiply it. 2 into 3. So how many elements we are having here? We are having 6 elements. This is very important topic because sometimes in your questions they are asking you order of matrix also. Now next we'll see notation for the elements of the matrix, okay, notation for the elements of matrix. Now here children, we are going to see for each elements what notation we are using, okay. If your matrix is of order m by n, then we will write it as, if A is your matrix and each element, in that case we represent it as Aij, okay, Aij, and it is of order, this matrix is of order m by n. In this condition, I represent what? Ith row, okay, means this elements comes in which row, okay, and J represent jth column. J represent jth column, means this elements comes in which column, okay, this elements falls in which column. The I term represents it comes in particular elements, it comes in which row, whereas the J represent the J, it falls in which column. Clearly, let's see here. Let A equals to, this is the matrix of order 3 by 3, okay, I am taking in matrix of order 3 by 3. If a matrix is of order 3 by 3, now this element A, so you know it will have okay, since it is of 3 by 3, so how many elements it will have? It will have 9 elements, okay, whereas this is what? This is your row, okay, this is first row, second row, third row, because how many rows we are having here? 3 rows. And how many columns we are having here? 3 columns, first column, second column and third column. For your confusion, you should not get confused, that's why I will write it. This is your first row, this is your second row, and this one is your third row. Okay, this is your third row. This is your first column, this is your second column, this is your third column. Now this is the matrix of order 3 by 3, in which we are having 3 rows and 3 columns. We are having 3 rows and 3 columns. Now this elements, it falls in the first row and the first column. So that's why its notation will be what? 1 and 1. First row, first column. This elements, it falls in the first row. But which column? Second column. So 1, 2. This elements, it falls in the first row and which column? Third column. So its notation will be 1, 3. Same way, this elements, it falls in the second row and which column? First column. So that's why 2, 1. The notation of this matrix will be, it falls in the second row and which column? Second column. Same way here, it falls in the second row and which column? Third column. So the notation of this matrix will be, it falls in which row? It falls in the third row and the first column. So 3, 1. This elements, it falls in the third row and the second column. This elements, it falls in the third row, third column. So this is what, in this way we are doing notation for each elements of the matrix. Okay. Now let's see diagonal elements of matrix. For example, if your matrix is A equal to 2, 3, 4, 5, 6, 7, 8, 9, 2. If this is your matrix, so in this matrix, the diagonal elements are this 2, 6, and this again 2. The elements which falls diagonally, that we called it as an diagonal elements of matrix. Now let's see some special types of matrices. Now let's see some special types of matrices. Very first is very first is row matrix. Now, what is row matrix? A matrix having one row is called as row matrix. Means if a matrix is just having a single row, okay, a matrix having one row is called a row matrix. Row matrix, okay. For example, like here A equals to 2 and 5. How many rows it is having? It is having just one row. So what do we called it as? We called it as row matrix. Take another matrix B 3, 4, 7. Okay. How many rows it is having? It is also having one row. That's why it is also called as an row matrix. Then the second one is column matrix. Then the second one is column matrix. Same way, a matrix having one column is called as column matrix. If a matrix is just having one column. Then we called it as a column matrix. For example, A equals to 4 and minus 1. 2, 3, 6. How many columns it is having? It is just having one column. That's why we called it as an column matrix. Then the next term is rectangular matrix. Rectangular matrix. A matrix in which the number of rows is not equals to number of columns, then we called it as a rectangular matrix. Means when your number of rows and number of columns are not equal, that time we called it as a rectangular matrix. Like here, example, A equals to 2, 3, 6, 4, 2, 1, 8, 2, 3. Okay, I have to write an example of rectangular. Now this is your matrix. Okay, 2, 3, 4, 2, 8, 2. Now here, how many rows are there? Here we are having 3 rows. Okay, and how many columns are there? 2 columns are there. So what is the order of this matrix? The order of this matrix is 3 by 2. Okay, the order of this matrix is 3 by 2. Another example I'll take. 5, 3, 2. 1, minus 2 and 4. Now here in this example, how many rows are there? There are 2 rows. And how many columns are there? There are 3 columns. What is the order of this matrix? 2 by 3. Now what is your rectangular matrix? In rectangular matrix, number of rows is not equals to number of column. In rectangular matrix, number of rows is not equals to number of column. Number of rows is not equals to number of columns. Okay. Then the next one is square matrix. Now, in square matrix, the number of rows is equals to number of column. Square matrix is a matrix in which number of rows is equals to number of columns. Now let's see here. A equals to 2, 3, 4, 6. B equals to 3, 6, 9, 4, 2, 6, 2, 3, 4. Now here, if you see these two examples, in these two examples, here how many rows we are having? We are having 2 rows and we are having 2 columns. So order of this matrix is what? 2 by 2. Same way here, how many rows are there? 1, 2, 3. How many columns are there? 1, 2, 3. Now if you see here, the number of rows and number of columns are equal. In both this example, in the first one you see here is also number of rows is also 2 and number of columns is also 2. Same way here, number of rows is also 3 and number of column is also 3. So when number of rows is equals to number of columns, then such particular matrix we called it as square matrix. Then next, diagonal matrix. Number 5, diagonal matrix. in diagonal matrix, it is a square matrix. Diagonal matrix is a square matrix in which every non-diagonal element is 0. So we called it as a diagonal matrix. For example, A equals to 1, 0, 0, 2. One more example, I write it down. 2, 8, 4, 0, 0, 0, 0, 0, 0. Now, what is diagonal matrix? In diagonal matrix, the diagonal elements are non-zero element. Okay, very first thing, diagonal matrix should be a square matrix. The condition needed for diagonal matrix are which? Very first, it should be a square matrix. Okay, it should be a square matrix. Okay, then the second thing is what? In which every non-diagonal element is 0. In this, every non-diagonal element is 0. Okay, the second condition which is needed is non-diagonal element must be equals to 0. Now here, if these two examples you see, in these two examples, here we are having the diagonal elements. Okay, and the non-diagonal elements are what? 0. Here also the diagonal elements are there and the non-diagonal elements are which? The non-diagonal elements are 0. So it is called as what? It is called as an diagonal matrix. Moreover, if you see how many rows are here? 2. How many columns are there? 2. So number of rows and number of columns are equal. So that's why it is what? It is a square matrix. Same way here, number of row is how much? 1, 2, 3. Number of column is how much? 3. So 3 by 3. So this is here also number of rows and number of columns are equal. So it is also a square matrix. Okay. So for diagonal matrix, two things are needed. Very first thing, a matrix should be a square matrix and the non-diagonal element should be 0. Then the next one is your unit matrix or identity matrix. Unit matrix, which is also called as identity matrix. A square matrix in which every diagonal element is 1 and every non-diagonal element is 0. Then we called it as a unit matrix. Here also for unit matrix, which three things are needed is, very first is it should be a square matrix. As soon as the word square matrix comes, you must know that number of rows must be equals to number of columns. Then the second thing is diagonal element should be 1. Diagonal elements should be 1. And the third part is what? The third thing which is needed is non-diagonal element should be 0. Non-diagonal elements must be 0. Okay. Now let's see with the help of an example. Here A equals to 1, 0, 0, 1. Another example. Now very first you see, very first we will write down the order of this two matrix. The order of this two matrix is the very first one of this. How many rows? Number of rows is 2. Number of columns are also 2. So the order of this matrix is 2 by 2 and the order of this matrix is what? 3 by 3. Okay, order of this matrix is what? 3 by 3. Here if you see, the diagonal elements are 1 and the non-diagonal elements are 0. Same way here in this example also, the diagonal elements are which? The diagonal elements are 1, whereas the non-diagonal elements are 0. So this such kind of a square matrix is called as unit matrix or identity matrix. Now let's see zero matrix or null matrix. Okay, zero matrix is also called as null matrix. A matrix in which every element is 0. A matrix in which every element is 0 is called as your zero matrix. For example, A equals to 0, 0. Okay. B equals to, means if each of the elements are 0, then such matrix is called as an zero matrix. Then the next term which we are going to see is comparable matrix. When we can compare two matrices, okay, when we can compare two matrices, let's see that. Two matrices are said to be comparable if they are of the same order. Two matrices are comparable if they are of same order. When you can compare two matrices? If order of both the matrices are same. For example, A equals to 2, minus 3, 0, 5, 1 and minus 4. And B equals to 6, 7, 1, 8, 0, 9. The order of both this matrix is what? If you see, the order of both the matrix is 2 by 3. So when the order of both the matrix are same, so you can compare that matrix. When order of both the matrix are same, in such case you can compare that matrix. Otherwise you cannot compare that matrices. Then the next term which we are going to see is equal matrices. Now, when do we say two matrices to be equal? The condition needed for it is, number one condition which it is needed is, both the matrices should be of the same order. A and B matrices must be of same order. And the second thing which it is needed is their corresponding elements must be equal. Their corresponding elements are equal. Their corresponding elements are equal. Now let's see with the help of an example. Here I am having two matrices. A equals to 0, 1, minus 3 and 6. Okay, and B is equals to 0, 1, minus 3 and 6. If you see here, the order of both these matrices are same. Okay, what is the order of this matrix? The order of A matrix is 2 by 2, and the order of B matrix is also 2 by 2. The order of both the matrices are same. Okay, and if you see, each elements are also same. First one is 0, 0, second one is 1, 1, minus 3, 6, 6. If you see, each of their corresponding elements are also equal, then we can say that these two matrices are equal. We can say matrix A is equals to matrix B. Next is transpose of matrix. In transpose of matrix, let any matrix be there. Okay, then the matrix which is obtained by interchanging the rows and the columns of A is called transpose of matrix. Now you see, means rows we are changing it by the columns, and columns we are changing it with the help of the rows. So now let's see how we are going to change it. So the transpose of this matrix will be, so this rows I will make it as columns, so it will become minus 2 and 7, and this minus 2 and 7, and this will be 5 and minus 4. Means the rows we are making it as column. Same way here for this B matrix, transpose of B matrix will be 2, 3 and minus 5, and 1, 0 and 6. Same way transpose of this C matrix will be minus 8, 9 and 2. So this is the basic concept part of the matrix which you should know.